Why might our listeners be interested in the concept of resilient machine learning related to whatever their kind of data science modeling is, or the kind of software engineering that they do, or the kinds of systems that they architect?
So, building systems that are resilient to changes in your customer distribution is a constant issue that every data scientist faces, especially at a growing business. When you have your initial set of customers and there's an initial behavior that's present in the kinds of data that you're seeing, you want to be able to build your systems so that when that distribution changes, when new customers are onboarded, you are able to quickly adapt to these new distributions. And so there's two main principles that you could apply towards having this kind of quick adaptation to new customers. One is fast retraining. Maybe you build a machine learning model, you train it on your data, then you have new data that's coming in. If you have assembled a concrete, coherent data pipeline and data labeling pipeline, then you'll be able to retrain your model. And sometimes you could even automate the retraining process depending on the nature of your data and the environment that you're operating. Another approach that we lean into both of these approaches at Abnormal Security, but one more approach that I think is very under-discussed for quick adaptation, but has a lot of usability in this kind of case, is to utilize features that represent the data distribution itself. And so to make this clear, perhaps rather than have a categorical feature to represent something like a user, that's like, this is this user's ID, we're going to represent them with a single value that's going to go into a one-hot lookup, then you're sort of expecting the model to memorize this user. And if this user changes their behavior in the future, you need to retrain the model to update it. An alternative is to utilize features like, what are the number of accounts that this user has followed in the last 10 days? Giving a Twitter example, what are the topics that this user has liked on tweets in the last 7 days? So these are features, but they're features that represent current data. They represent the past. At Abnormal, this is the aggregate features we were talking about earlier. How many emails has this person received from this kind of account at this point of time and day in the past? This is a feature representation of the current information. And so in the case where you have one customer that you're building a model on and then another customer that gets onboarded, even if that second customer is a very different distribution. Maybe that first customer only had a 10-person customer service team. This new customer has a 500-person customer service team. As if you've represented what it means to be a customer service agent in terms of these kinds of signals, like how frequently does this person receive emails from the outside, as opposed to things like memorizing who these individual people are, or even memorizing like a categorical signal on is customer service, then you'll be able to better adapt to these kinds of new circumstances because your features themselves will be modified and will adapt to this new distribution.